And hi everyone, and thanks for joining today. So in this webinar today, we're going to cover agentic AI, which is probably the hottest topic in the industry right now, with our unique angle, which is around secure collaboration. So when you're building agentic AI, obviously one of the big challenges is around security and how you make sure that there's no data leakage, there's no compliance violation. And this is our angle, and the discussion today is going to be around building agentic AI and do it in a secure way, especially when it comes to secure collaboration, when you need to build those flow across organizations. My name is Adi Irstein. I'm running the product management at Duality, and I'm joined by Zohar Duchin, who runs the data science. Hi, Zohar. So we're going to start from top down. So I'm going to talk about the huge shift in the market today, this huge paradigm shift of building software using agentic AI. So we'll talk about what it means and what it means to building applications, and then talk about the privacy and the security challenges around it. So when you build agentic workflow, what are the security measurement and concerns that you need to take under consideration when you build those? And then that would lead us to talk about privacy enhancing technologies and how we can leverage pets in order to protect the data and protect the models when you build agentic AI flows. Then Zohar will go deeper into the technology, covering the agentic flow and how you actually build those flow in combination with privacy preserving technologies. And we'll wrap it up with a live demo. We're going to introduce a new capability that we have that is called Duality Assistant Agent. Essentially, it's a new way to interact with the system based on agentic workflow. So as a user, instead of going to an interface, traditional interface, you can actually create all kinds of agentic workflow and use chat-like interface, for example, to interact with the system. And there are tons of advantages to do that. We're extremely excited about this new capability, and we're going to demonstrate that later on based on real use case from healthcare. So that's the agenda for today, and we'll wrap it up with Q&A. So let's get started. The shift in the industry is a huge paradigm shift. And the way I see it is that we're actually moving from AI as a feature to AI as an environment. So we are all using AI, obviously. We're building multi-step pipelines, usually with RAG and LLM, for all kinds of use cases. Could be summarization, could be predictions, tons and tons of use cases that we're already building in ITs that are leveraging LLMs and multi-step pipeline. But those are all features, if you think about it. We're using AI as a feature, it's very deterministic, and it's really good with certain tasks. The huge paradigm shift is to think about AI as an environment, not just yet another feature, yet another pipeline, but we're going to be surrounded by tons of agents, and each and every agent is going to have their own goals and their own tasks and their own tools. And that's a completely different environment. So think about an environment where you're surrounded by those little things that can do so many things that are not deterministic. You basically provide them a goal, and they can make a decision based on the goal on how they are going to perform their task, what kind of tasks they can do. And because of the fact that they're self-decision making and they don't follow a very deterministic task, they can basically decide that they can do X or they can do Y. In some cases, they would use the result to calculate what's going to be the next step. And it's a completely different way of building applications. It's a completely different way of solving problem and building pipelines within the organization. So while it brings tons of benefits, it also brings lots of security and concerns around it. The other thing that those agents are capable to do is to have some sort of a contextual memory. So they know what they did in the past. So they can actually leverage and based on the history and take some data in order to calculate what should be the next task that they need to take. Contextual memory is another characteristics of those agents. And the other thing is that those agents can take actions. So they can send emails, they can create records within systems, they can do all kinds of things. So it's not just an interactive interface, chat-like interface, or generating reports. It can actually take actions and trigger different APIs and all kinds of tasks within the organization. So again, think about this paradigm shift moving from AI as a feature to AI as an environment, and suddenly we have tons of small little agents that can do different things. If we take an example, let's take this example around cross-department budget planning. So how does it look like? We have data in different departments, IT department, financial department, and then we want to build a model or agentic flow that knows how to do budget planning based on the data that comes from different departments. So the way we do it today is typically by taking this data to a centralized place, usually some sort of a data lake, and then we have an application that runs a very deterministic logic and essentially generates a report out of it. Still using AI, but in a very kind of centralized way. When we build agentic flow, it looks completely different, right? We have different agents that have different responsibilities. So the first one in this case is an agent that is responsible for data collection. So we have an agent that gathers the data from the IT department, financial department. They take input like cost center data, forecast. They can take input from the FSI department, like revenue projection and expenses, and then they transfer that input to the next agent. The next agent is about modeling. So it can create budgets, different budget scenarios, play around with different scenarios, and pass it over to the next agent. And the next agent is about resolution. So it needs to detect conflicts, things like overspending, even negotiation with the different departments. And that goes on to the next one, which is going to generate a draft. And the final agent is going to basically generate a finalized report. So the thing is that it's an autonomous agentic flow, and each and every agent can basically take different or slightly different way to approach the task that they need to do every time that they're operating. For instance, this data collection agent can decide that in the next iteration, it's going to take more data, not just the cost centers and the forecast data. They can actually have access to other data and they can utilize that. And when it comes to budget scenarios, obviously they can come up with different scenarios every time. So everything here is really not deterministic, and they can trigger different actions along the way. So that's a typical agentic flow around budget planning. And with these huge benefits of it, there's also challenges. And the challenges are around security, mainly around security. And in a very high level, the security challenge boiled down to data leakage and compliance violation. And if we break it down to what are the capabilities of the agent and the security requirements that present, we can see that there is a new things that we need to address in order to mitigate those security concerns. So the fact that those agents are dynamic and they can create dynamic workflows and they're non-deterministics, it means that they can take different actions, they can figure out different ways to do things, and we need to have better control, a new way to control that agentic flow. The fact that they have memory and context, it means that they can store sensitive data along the way and they can use that sensitive data. So how do we governance that? How do we make sure that this sensitive data that is part of their context, part of their memory, is not something that is being leaked? Then the fact that they can actually execute different things, different tasks, they can run APIs that call different systems and creating new records or sending emails in very autonomous ways. It also means that we need to have runtime security to make sure that not exposing any sensitive data. And in between those multi-agent collaboration, you obviously need to transfer sensitive data between those agents, right? So how do we secure the communication? How do we make sure that we have the policies in place so each agent can actually take care for data that they are allowed to do, and there's no leakage during that communication transformation. And last but not least, when it comes to cross-organization collaboration, then obviously you need to transfer data from one organization to the other organization. So how do you protect this data? And this is where pets come in, and this is basically the focus of our webinar today. So, any thoughts on your end around those security challenges?
Yeah, I guess you put it very correctly. In a general way, I think that an agent is a small person, and there's a lot of know-how within an organization about employees, for example, that know what they can do, what they cannot do according to policies or training that they have in the organization. With agents, suddenly they have almost the same power, access to data and to different operations like human beings, like the employees, but they didn't go through the training about what is allowed and what is not allowed. And therefore, there is all this need to have these controls and governance and security around their operations in order to ensure that doing these operations with agents is still comply with the security and the policy of the organization.
Yeah, I completely agree. And I think that the bottom line here is that we need different way to secure the data, right? We need to find different measures in order to make sure that everything is secured when it comes to agentic flow. And specifically when we're talking about cross collaboration and building agents between different organizations, that is even more challenging. And this is where privacy enhancing technologies comes in. So we're using different technologies. I guess that most of you here in the webinar are aware of this in a very high level. But when we talk about privacy enhancing technologies, basically there are a couple of them. The first one is fully homomorphic encryption. So fully homomorphic encryption is all about taking data encrypted and run operation on encrypted data without decrypting the data. So it's very secure, post-quantum, and this is one of the pets that we're going to talk about. Second one is federated learning. So federated learning means that you can analyze the data where the data resides. So by definition or by design, the data never moves. So you can analyze or do the heavy lifting where the data resides. Only the intermediate weights or intermediate results are being sent to some sort of a global server to create a global model or global aggregation. Then the third one is trusted execution environment, which is more like a hardware-based solution to protect your data. And all the cloud vendors, AWS, Google, Azure, they all provide those unique servers that are called trusted execution environment or confidential computing. And essentially, it's an isolated box where you can process data in this isolated environment where no one can access it. And the process, basically the memory is encrypted, the operating system is not shared with the global operating system. There are all kinds of things that make it completely isolated. So those are the three main pets that we typically use. And on top of that, it's not only about pet, but you also need to have governance and control in place. So even if you're encrypting the data, it's not enough. You need to make sure that there are governance in place and you have, as a data owner, the ability to say who can access the data, at what frequency, what's the policies around it, and so on and so forth. So privacy enhancing technology is definitely a building block, a very important one, but you also need to have this governance and control. And it's not only about who can access the data, but it's also about the results. So how do you analyze if the results that are moving between agents are not revealing any sensitive information? So that's also a big part of the solution. So with that, Zohar, maybe go deeper into the architecture and how do we actually building those agents.
Thanks, Ali. So after we saw the agents and also the different technologies of security technology that allows security, but let's go one step backwards to better understand what is an agent and how it actually works from the inside. Agent basically is an autonomous application or an entity which is designed with a role and a goal and sometimes even a backstory about who he is and what his goal in life is to be. It also has the task that he needs to accomplish. Now, this task and all these things are being communicated through the chat or through the operator that tells him what to do. And the agent does it with the following things that Lee mentioned before. First of all, it has a kind of a brain, which is typically a large language model like OpenAI or Claude or DeepSeek, any large model that can understand the text and reply with instructions what to do, like the brain that we have. It also has the memory, so we can pull contexts from previous tasks that he did or previous resources that he used. And it has also access to different tools and resources that allows him to either get more data, doing operations, whether to take contacts, whether to write down events in the calendar, sending emails or getting from the email things. All these kind of tools are also something that the agent can use in order to accomplish its task. So this is the agent that autonomously tries to accomplish the task and return with a complete answer to its operator based on several, even many iterations with all the resources that he have and with the language model that allows him to use them. We'll go to the next slide to even go further to an environment where you have multi-agents. And over here, there is a flow that is a bit, that we need to think about it in a different mental framework. The way that I like to think about it is everyone who builds multi-agent flow needs to think team manager that hires several junior employees that helps him to accomplish its task. In order to do this, he needs to define clear goals, to define or give them access to the right tools that they have, define what are the tasks that he have, and also needs to define about the information flow, how things can flow between the different agents in order to accomplish this task. He needs to think about the size of the team that he builds, right? Because if it's too many, they might, each of them step on each other's toes. If it's too small, then maybe it's not focused enough. So the right size, like building a team, is a very similar mental framework for building a multi-agent flow. There are typically several flows that we can use, or typically there are for a multi-agent flow. First one is the hierarchical flow, like the teams that we work at. We have a team manager that assign tasks to the different employees or different agents according to their specialty and roles. One of them will be a researcher, one of them will be a writer, right? So it's a different task that the supervisor decides how to assign the different tasks to the different agents. Another flow is the network, which everybody can talk with everybody and everybody can assign tasks to other agents. It also things that can work and there are benefits for this flow. And of course, everything in between, custom flow, according to the way that as a manager, you think the goal or the tasks, high-level tasks can be achieved, so you can design it the way you want. Now, first of all, this thing is in the research front. It's every day there are different best practices and the findings that are out there. But even here, you can think about what happens if these agents are in different departments, for example, or different organization even. How do you control the thing that is being passed from the supervisor to between different agents within different organizations? How does he control whether it is legitimate or whether he leaks data to a place where this data cannot reach? If an agent, for example, is running a code, right, is basically to achieve a task, it needs to write some code and execute it. How we make sure that this code is not malicious, for example, and how we make sure that this code runs in a safe place. So all these kind of considerations now becomes a thing that we have to think about in order to run these kind of flows of multi-agent flows in a correct way.
So what about the protocols of communication between agents? Do you want to talk a bit about that?
Yeah, excellent. So again, this is something that is quite new or gaining traction. because the way that until a few months ago agents communicated with each other was everyone did what they want, right? There are two protocols now that are rising and we can choose between. One is the A2A, which Google supports, which makes standards around the way that agents communicate with each other. And the other one is ACP, Agents Communication Protocol, that is supported by IBM and also gaining traction. And both of them are basically putting standards around how different agents are going to communicate. What do they expose? What is the protocol that they communicate with each other? And this makes the development of this agent's flow much more easy. Okay, so this is the multi-agent. This is where the world, I guess, is progressing towards. And now let's move back into one agent. And let's solve for this agent how we solve this issue of security. And then we can naturally expand it into multi-agents framework. So with one agent, and we remember that we have this issue of accessing data or accessing sensitive data between different organizations or departments within the same organization. So we need a way to make sure that things are being governed as needed, that the data is being processed in a secure place. And for this, if you remember a few slides back, we have this diagram of the layers of security, which starts with the PETS technology, the privacy enhancing technologies of homomorphic encryption or trusted execution environment or federated analytics. This comes to help over here. So you can see that no matter what the agent is, there are different frameworks over there for CrewAI or LineGraph, Google's ADK. No matter what the framework is or the large language models or storage, everything can be used. The tools, however, that are allowed to be used, these ones are tools that are being exposed through the MCP server that Duality technology, Duality platform exposes. And this basically controls what are the things that the participants, whether it be organizations or department, allows to do with their data. So you can't do whatever you want, or the agents cannot do whatever it wanted to do because it's decided this is needed. It can choose and do things with the tools that are being exposed to it from the MCP server. Furthermore, the operation of these tools leverages the privacy enhancing technologies in order to execute these tools in a secure way. Meaning, for example, that if join of datasets needs to be done from different organizations, then it will be done within a trusted execution environment and prevent leakage of information between these organizations. Or if there is a need to train a model, for example, with two datasets that are sensitive and cannot go out of the organization domain, then a federated learning tool can be used in order to train a model, for example, using this sensitive data. So basically, all these resources and tools that are exposed through the MCP server are being protected by both the governance that the platform provides, as well as the privacy enhancing technologies that allows them to run in a secure way.
So the cross-border cancer analytics, basically the use case here is that we have two medical centers. One is the UK, the other one is in the US, and they need to analyze pediatric cancer. Now, pediatric cancer is a rare disease, and they don't have lots of data, fortunately. But at the same time, they want to be able to analyze this data and come up with better research insight. So the idea here is to provide them a way to get more data and to be able to analyze broader set of data across multiple organizations. And the challenge is obviously that they cannot share this data. This data is very sensitive. They cannot just share it as is. And this is where Duality comes in and provide them a platform where they can actually analyze the data, run their research, while making sure that the data is completely protected. They cannot see the raw data. And here we're using a couple of privacy technologies. We're using federated learning, TE, and even differential privacy. And at the end of the day, they can get more optimized and enhanced analysis based on much broader data sets and faster time to research. So that's the overall use case. And when we look at the architecture, this is how it looks. So we have a couple of medical centers using federated learning or federated analytics in this case in order to run the analysis. So by definition, when we work with federated analytics, it means that the computation is running where the data resides. So the data never moves, but there are intermediate results that needs to be sent to some sort of federated aggregator in order to aggregate the results, and this data could be sensitive as well. In order to protect this data, we're using trusted execution environments, which I mentioned earlier. This is a way where we can encrypt the data, send it to this trusted execution environment, which essentially is an isolated box. And over there, we can analyze it while making sure that nobody can have access to the raw data. By the way, not even the cloud vendor themselves. They cannot see the data, they cannot see the process, nobody can access it. And then, because this is very sensitive information and it's rare data and we don't have lots of data, we also need to add some noise to the results. So there's no way to do any kind of reverse engineering to the results and figure out something about the original information. So in order to do that, we're using differential privacy that adds that noise to the results. And this is where the agent comes in. And we're going to see that in a moment, where we're leveraging agentic AI in order to run those analyses. But using agentic AI, it can basically provide you all kinds of new capabilities that we didn't have before. And this is what the Duality Assistant Agent is all about. Again, we're very excited about this new technology and new feature. It gives you a couple of things. So this agent, first of all, it's connected to the data sets, it's connected to the workloads. So it knows everything about the system. So it knows the data, it knows the workload, which means that, and it has its brain, it has its memory, it has resources. So it can provide you guidance on what you can do with it. So even if you're not really familiar with the collaboration, you don't know exactly what resides in the collaboration in terms of the data sets and the workload, you can actually utilize this agent and ask him, what are the available data sets? What's the available workloads? What can I do with it? And continue from there. And it can provide you research guidance along the way. So essentially, you're actually getting some sort of a new insight, because you as a researcher, you can't think about all the permutation, but the agent can actually do it. So it can build you some sort of a deep research, very similar to the ChatGPT deep research, where you give it a goal and it can actually run and analyze different permutations and provide you a report at the end. It also helps with automation, because now you have this agent that can actually run all kinds of workflows in a very automated way. And we have customers that are running tens or even hundreds of workflow a day. They used to do it in some sort of a manual way or APIs. Now they can actually automate that using agents. And last but not least, the simplification part. The fact that it provides you a chat-like interface, it's not just a nice UI thing. It changed the way you interact with the system. I mean, we're getting used to interact with ChatGPT nowadays. There's no reason why enterprise software B2B is going to be different. And the chat-like interface provides you a couple of benefits. First of all, you don't need to know the exact column names in the database. For instance, in one organization, gender could be gender. In another organization, it could be sex. The date format could be different, right? The name of the disease or the state could be a little bit different. The researcher, you don't need to know this language anymore. You can just run simple English, and the agent knows how to translate it to a real workload with the real parameters. And that saves a lot of time when it comes to onboarding and really enhance the user experience overall. So let's see how that looks. I'm jumping over to the Duality interface. As you can see here, we have those two organizations, Medical Center A, Medical Center B. Each and every one of them has its own role, so they can initiate workloads. They also contribute assets, and they can receive data. So that's the setup. Now, if we go to the agentic AI, let's start with some prompts that I prepared in advance. This is the prompt. Basically, the prompt is saying that I'm a pediatric cancer researcher. I'm interested in that specific study, survival rate, and I want to know what are the data sets and the analysis available. Again, I don't know a lot about the system. I may have tons of data sets and tons of analysis here. I don't need to go through traditional UI, and I'm getting this response back. So I can see the column names for each and every one of them. There is a very clear description about what this data is all about. And then there is a list of available analysis, and again, with some description. So things like survival rate and response time and histogram and so on and so forth. So let's say that I want to run a comparison of a survival rate. I want to be able to analyze the outcomes across different cancer types. So this is one of the recommendation here. Obviously, I can use others, but this is just for the sake of the demo. And what happens under the hood, basically start computation based on the decision that this agent is doing. So if I'm jumping over to the Duality interface just to see what's going on under the hood, the researcher doesn't need to look at it. I can see that there is a workload that is running. It's basically picked up the observed survival rate, and it knows how to fill in the relevant parameter. Survival rate, there is also a notion of time beans in our data set. It knows how to select the specific event. So again, as a researcher, I don't need to know what's the name of this exact event in the database, but the agent knows. And then the event indicator and also other parameters. And you can see the results here, but if I go back to the chat interface, this is how it looks. So I'm getting a list of cancer types with the different survival rates and even a nice chart that shows different cancer types. So from here, I can continue. So I can see that with a specific cancer with very low survival rate, let's say that I want to analyze it furthermore and basically ask the agent, what else can I learn about this? I'm saying that this specific sarcoma cancer is a notable number of deaths. What can I do with it? Any idea for further analysis? And it goes from here and provides me, as you can see, tons of other ideas to analyze it based on demographic data, tumor characteristics, whatnot. So you get the idea. At the end of the day, it provides you tons of recommendation, and I can continue and analyze it. And so, for instance, analyze survival times for patients with that specific cancer by age. And we don't need to wait for that. I can show you how it looks in other session. So this is the survival time, the count of patients, and provides you additional insight with some bar chart based on age. So that's the idea. And again, it's all based on the fact that we have this agentic flow. It's connected to LLM. LLM is the brain of it. Then it has the memory. It knows all the historical chat. As a user, you can also configure it with resources. One medical center can basically upload a bunch of research that are relevant for this agent and make this agent a domain expertise in that specific topic. So you're creating an agent that is very dedicated to what you're trying to do. And in the platform, it's very generic and you can create your own agent. So it's not just for healthcare, right? You can create any kind of agent. It could be in financial space. It could be in the government industry. It could be anything, essentially. So that's pretty much it in terms of the demo. I think we're right on time.